chairman of this particular session. I would like to present a case study which has a amount of demonstration of integration of the technologies, which is one of the themes of this particular session, on a specific study related to the mapping of the diseases, hotspot identification, and epidemiological evaluations. The basic objective, the data has been collected in one of the provinces of Thailand. This is a WHO-sponsored program on modeling the health pattern and disease movement, vector-borne diseases, particularly in northern province of Thailand. The objective is to forecast the incidence rate of diseases by applying the empirical methods and to detect the disease hotspots under different years by using the local support and autocorrelation, etc., mathematical equations. For this specifically, the data is the medical data and the demographic data and the geospatial data has been utilized from the Thailand Space Department, and the data has been used particularly under 8 diseases have been grouped: diarrhea, pneumonia, food poisoning, malaria, influenza, etc., dengue fever, and hemorrhage fever of dengue hemorrhage fever, etc. And the years of data has been collected is about 6 years, roughly 18,000 types of diseases have been covered in this particular analysis. Essentially, the basic objective is to go for disease mapping of the diseases, then they conduct some correlation analysis, and I delineate the spatial patterns of these diseases and hotspot detection of diseases. Without going much details, I would like to only summarize here what are the results that could come out of this particularly analysis of the data using some of the technological tools. The study showed that these methods and tools can be useful for disease surveillance for public health officials, and using the health data and spatial data and GIS can provide opportunity to specify the health burden from diseases within the infested areas, and it could form a basis and a foundation for further analysis, and which are factors responsible could be discerned from this particular analysis. And I could skip this, but for disease mapping, the traditional method of identifying like the incidence rate has been somehow not widely accepted. For this particular problem, some technical methods like Bayes method have been developed to remove the random variability which is presented in the data from small population studies counts, and which can contribute to the smoothing of the maps with limited extremes in the estimation of the risk due to the various disease analysis. A flowchart has been 59 years, and the pneumonia cases were higher in the children under 5 years of the age. It could delineate what are all the diseases, what are the patterns, what are the spatial characteristics, what are the temporal characteristics, could be grouped, particularly related to studies fevers of unknown origin were highest in rainy season. The monthly case of fevers of unknown origin were significantly high correlated to the dengue fever and influenza. Wherever these fevers, the diseases are occurred, also fevers of unknown origin also, which require detailed analysis. It is concluded in the present study that the dengue fever and influenza have previously been observed as the causes of fevers of unknown origin in rural areas of Thailand. And we could identify about 84 patterns of clusters in this particular study, and these issues could comprehend the form of a local spatial statistic parameter for each village to detect the presence of significant local clustering of the 8 diseases over the 6-time period, or the 6 years of the period. And the statistical test results suggested that the significant local clustering of high morbidity rate of diseases or the disease hotspot could be discerned in Chiang Mai for successful years during 2001 to 2006, and this study also later being repeated for 2007 and 2009 on the request of the WHO. For the spatial disease pattern and hotspot detection analysis, the number of patients with disease was classified year-wise and village-wise, and a map of the entire area in the form of under a GIS domain has been prepared. And the spatial distribution of many infectious diseases is always correlated with the socio-demographic factors, environmental factors, sanitation, and also climatic factors. This type of correlation will help you to go for preventive measures and what type of measures for mitigation of the diseases could be taken by the public health officials could be identified. And the study has focused the spatial patterns, hotspots, and diffusion of AIDS disease in the local level. And this study has basically, as WHO has given a comment that exactly I'm reproducing, has practical utility in making timely risk maps that can be used to communicate disease risk early and make some sort of preventive steps. And in terms of the GIS, reconstruct the route of diarrhea, etc., we could identify the vector-borne diseases, monitor the vectors, movement of the vectors also. The comprehension of this study suggests that the need for modeling with systematic investigations among the other areas of outbreak and the whole province. There could be whether you can also predict whether there is an outbreak, what type of outbreak is estimated in a particular area, if the percentage of population affected in a particular area is available. So these are the technological tools for modeling and taking the public health officials appropriate decisions over a period of the time. Thank you very much.